One last thing I wanted to talk about in section 1.3 is this principle of conversion that they talk about, where it says step I plus 1 computation is performed on floating point result of step I. So in other words, what they're saying is this is step I, this is step I plus 1, I plus 2, and so on. And what you want to do is, when you're calculating your vertices, for example, in this triangle example, what we did was, in subsequent vertices, we had these floats, A1, XA1, YA1, and so on, and we used the first floats that we started with, the XA and the XB, to calculate these floats, right? And so when we did the drawing, we used integers, right? We converted to integers with the IX and IY. But when we were doing our calculation of subsequent vertices, we went from float to float. So we used this float and this float to calculate this float, for example. So I just want to demonstrate how that can, so this is the way we did do it, and then they say, oh, you want to avoid doing this. You want to avoid going from float to int and then using that int to give you your subsequent float value. So I just want to show you how that can get you in trouble, so we can avoid it. So I'm going to start off just looking at the first triangle that we draw from A to B to C. Okay, the side lengths are all, have the value side, and then side half is 1/2 of side, and H, the height of the triangle, is side half times the square root of 3. And it's this square root of 3 business that's going to give us little extra bits that we need to worry about as we're, so we don't accumulate error. So let's see. Okay. We start off with, we started off with the first triangle. Now, what I did was here, I just modified the code so that it would draw 2 triangles instead of 50. And I just want to talk through what's happening here as we go from, I just want us to look more closely as we go from, here's A to B to C, and then we can call this A1, B1, and C1. So if we can really put the origin wherever we want, even if we're using, device coordinates, we could manipulate those however we want to set the origin. So just for simplicity's sake, I'm letting the origin, I'm saying let the origin, or let point A be at the origin. So this is going to be 0, 0 for this example, and the length of the side be 100. So this is not the same origin or side length as we had in the actual code, because the A is calculated off of the x center, and the side length gets modified by a scaling factor. But just to make things easy for us to start off with, I'm going to say A is at the origin, the side's 100. Then side half, if side's 100, then side half is going to be 50, and H, the height of the triangle, is going to be 50 times the square root of 3. So what I did was here is just go through and did the calculation. So in the actual code that we wrote, we set it up so that P would be 0.95 and Q would be 0.5. So I'm just doing those, P times XA plus Q times XB calculations here. And you see some of these are going to come out looking, with a lot of decimal places, because we have this this original 50 times the square root of 3 up here. So if we do, so what I did was I calculated these numbers, and then I calculated these distances. So going from the distance from here to here I calculated, and the distance from here to here, and the distance from here to here, and those all came out nicely to 5. But if we round those numbers, if we take these calculated values and round them, you'll see even in this very first inner triangle that we start to get things off a little bit. So the distance from here to here is 5, but the distance from here to here comes out to be 4. And the distance from here to here is 5 again. But you can see things are already starting to get messed up. So what happens if we continue this for 50 is we get this yucky thing. And the way that I set this up, let me just show you the code. So I did of my that example here. I made these in the calculation of the next vertices. I made all these guys ints, the XA1, YA1, and so on. And so what I did was I said, okay, we'll convert all these to integers, and we'll feed the integer values in. And so what happens when we do that? Let me just show you. Run it. And fit it in the screen. Looks kind of yucky. I'll run the regular one for comparison, just so you can see a little better what I'm talking about here. They both still kind of look like spirals, but let me shrink this one down. But you can see the one on the left is the one that has the rounding errors, has the problems, and you can see what happens. It gets kind of messed up, and it's kind of more obvious as you shrink it down some more there. With the one where we kept with the convention of going from float to float, we were able to keep our triangle nicely in the middle, but things got thrown off when we used the wrong conversion pattern. So that's it. So just be careful about making sure that you're going from float to float, and only converting out to ints when you need to draw.